Hello everyone, welcome to part 10 of JavaScript. In the previous session we have talked about different concepts like what is DOM, how we can manipulate different elements of HTML and CSS using the concept of DOM, and we have seen what are events in JavaScript. We have implemented different events in the previous session. Now in this session what we are going to do is that we are going to talk about some of the advanced concepts which are really important when we go into backend development. Okay, so the first concept we are having is call stack. We have already studied stack in our previous sessions. When we studied DSA, we have studied about stack. Stack is a data structure. To be specific, it is a last in first out data structure. Now if you don't know anything about stack, let me tell you in clear terms, in a simple terms. Let's say that you are having books like 10 books or 20 books. Now you are arranging this 10-20 books on top of one another, right? So the structure which is formed when we arrange books one top of another is a structure. The structure is basically a stack structure, and we have seen stack in our real life many of times. For example, when you are in kitchen and when you are arranging plates on top of another, it is a structure of stack. Similarly, in programming we have a data structure called as stack, in which what we do is that we arrange pieces of code, or you can say pieces of function or elements, whatever it can be, on top of one another, and the structure which is formed out of it is a stack. Now if you want to imagine how a stack will look like in programming, then a stack will look something like this, and in this we will store elements one top of another. For example, let's say that in programming I am having elements A, B, C, D, and these elements can be anything. It can be data, it can be functions, whatever the element may be. Now what we are doing is that we are taking each and every element and we are arranging each and every element on top of one another, right? So here first of all, let's say I am taking A, after that I am taking B, after that I am taking C, after that I am taking D. So this structure which is formed is known as a stack in programming, and stack is a last in first out data structure. What is the meaning of this is, let's say here you can see that the first inserted element is A, after the next inserted element is B, after the next inserted element is C. Now if you notice, the last inserted element is D. Okay, now in this stack, for example, let's say the name of the stack is yes. Now in this stack, yes, I want to remove elements. Now when I start removing the elements, you can easily observe that the first element which has to be removed is D. After that I will get C, after that I will get B, after that I will get A. Now if you observe, you can see that the first element is A, which we have inserted, but in the output screen the last element is A. So from this we can extract one thing, that the last element which you have inserted, while removing that element will come out first. Here you can see that this is the last element, but in the output screen when we are removing the elements, this is the first element which we got as an output. That is why we call this data structure as last in first out data structure. Now you might ask, Jabir, we have understood what is a stack with real-time example and you have shown me the diagram, but why you are telling this? Like, stack is a programming topic, right? But we are doing development. Why you are telling this to us? Because we have studied functions, we have studied object literals. Now whenever we call a function, for example, let's say that I am creating three functions. I am creating a function hello, and hello function is calling some function world, and I'm creating a function world, and world function is calling another function human. Okay, now I'm taking as an example to make it very simple to you guys. Here I'm creating human. Now this is my human function. I'm having some lines inside my human. Now this is my index.js file, and in the index.js file I am calling first of all my hello function. Now what happens is that the initial control, you need to observe one thing, that here let me show you. In the VS Code, I will go in my VS Code. Now first of all I will import my boilerplate code, and I will connect this body, I will connect this HTML tag document with my index.js. So I will write index.js. Now here I will create a function. Let's say I am creating a function hello, and I will write world. I will call my world function. So here, let me remove this. I will call my world function. The hell, why this is coming? WRLD. Okay, this is absurd, totally absurd. WRLD. Okay, I am calling my world function. Now in the world function, I will create a function world. In the world function, I will call my human function. Right, this might be a little weird why we are doing all this, but believe me, give me a few minutes. Okay, so here I will call function human, and in the human function I'm gonna print console.log, and I will print hello world am human. Okay, so you can see that first of all, in the hello function I am calling world function. Now in the world function I am calling my human function. In the human function I am printing hello world I am human. Okay, now this is the three functions which we are having. Now I will call my hello function in the main program. So in the main program I will call my hello function. Save the document. Now I am gonna run this. So I will run this here. You can see when I run the document, let me inspect it. Go to console. You can see first of all I'm getting the output hello world I am human, but in the program I'm not calling human function. Then the question is how I'm getting it. I'm not calling directly human function. If I'm not calling human function, then I should not get this output, but how I'm getting it. So what is happening is that initially the whole control flow is in human function, main function. Okay, now main function is calling hello function. So main function is calling hello function. Now in the hello function, what I'm doing, I'm calling my world function. So this will go to world. The flow control will, overall control of the program will go to world. Now after world, inside the world, what I'm doing, I'm calling my human function. Now in the human function, what I'm doing, I'm printing console.log hello world I'm human. So like this, implicit indirect stack will get created in the program, and let me show you in a diagrammatic format also. So here I have created three functions, and in the main program, initially in my main program, okay, in the main program I am calling my hello world. I am calling my hello world. Now what hello world is doing is, hello world is calling world function. Okay, and world function, in the world function what I'm doing, I'm calling my human function. So here this will call human, and in human what I'm printing is, I'm printing hello world I am human. Whatever the output is there, I'm printing that. After that I am returning back to my world. After world I am returning back to my hello, and finally I'm coming back to my initial function call location, which is my main program. Like this, we call this structure as a implicit stack. A indirect stack will get created in the program, and this is really important in development as well, to understand how function calling is happening. For example, let's say that we are having different functions and there is an error in our function calling. Now we need to understand it. We have to understand from where we are getting the error. So to understand that, it is really important to understand the concept of stack, because all the functions calling are happening in the form of stack, and if you don't know what is stack, then how you're gonna resolve the problem? That is why the call stack, understanding the concept of call stack is really important. Now let us visualize call stack with an example. Here you can see that I'm having a function called as 1 and 2 and 3. Okay, now let's say in the main program I am calling my 3 function. Okay, so here let's say this is my call stack. Initially the call stack would be empty, or you can say I will be in my main program. Now main program will call 3 function. Main program will call 3 function, and here I will print the output. Where as we go up, I will print the output. Okay, so here I will call my 3 function. Now in the 3 function, the first line is I am creating a variable let ans is equals to 2 3. I am calling my 2 function, I am calling my 1 function. Here the first function calling is 2, so this will call 2. Now the overall control of the program will go to 2 function. Here I will come in my 2 function, and in 2 function the first line is I am going to return this sum of 2 values. So first of all I will call 1, so this 2 function will call 1 now. Okay, now in 1 what I am doing is I am returning 1, so here this will return 1. Okay, now this will return 1, and after returning the value, this frame, we call this as a frame. Here we call this each box in the stack as call frame. So the call frame will get like you can say erased when we return or when we complete the function. Here you can see that I am completing the function, I am returning something. When I return something, the call frame in the call stack will get erased automatically here. So the call stack will get erased by returning 1. Okay. Okay, now after returning the program, what is the next function call? The next function call in 2 is again 1. So this will call again 1, and 1 will again return 1. So here the returned value will be 1 and 1. Now you can see the overall function calling of 2 is completed. Now when the overall function calling of 2 is completed, what it is returning? It is returning the sum of 2 returned values. Here you can see that the first returned value is 1 and the next returned value is also 1, and it is going to, the 2 function is going to add the 2 returned values. So here the 2 function, first of all it will return, let me choose the pen. Okay, so this will return 2 as the output. First of all it will return 2. Now after returning the value, the call stack will be erased. Okay, the call stack will be erased here. Okay, after erasing all this, now what 3 will do is that the next function calling is 1. So 3 will again call 1. Now 1, what is 1 doing? 1 is returning, basically 1 function is returning 1, so the return value will be 1. Okay, now after this again the call stack will be erased. This is a little bit slow, I know, but it is important to understand. Okay, now we have returned here. Okay, now after getting the 2 returned values, we are summing, we are like adding those 2 returned values. So the returned values are 2, 1. So we are gonna add these 2 values and we will return the output to the main program. So in the main program we are gonna print 3, so the output will be 3. Like this we visualize a particular stack. Now we did all this manually. Now if you want to see, let's say we have 10 functions, 20 functions, we can't draw it, right? So to visualize how stack is creating in our program, we use a concept called as breakpoints. What are breakpoints? Breakpoints are the most, you can say, important concepts which we use to check how a particular line is executing. For example, let's say that I am having these 3 functions. Okay, I am having these 3 functions in my program. Now I want to check how the function 3 is executing. What is the flow of function 3? How call stack are forming through function 3. So to check the execution of a particular line in a program, we use breakpoints, and breakpoints is used for debugging, right? What is debugging? Let's say that you have thousands of lines of code and there is error and you are not understanding why we are getting this error. So at that point what we do is that we will debug our code, and using debugging we can understand, okay, why we are getting this error, what is the reason behind this error, right? So the breakpoints are used. First point, it is used to check the execution of a particular line, or you can say set of lines in our program, and breakpoints are used to check error. or you can say it is used in debugging process. Now let us see how we can use the concept of breakpoints and how we can visualize our call stack automatically. In our browser, we can clearly see how we are getting the call stack. Okay, so let me show you, everything will be clear, no need to worry at all. So here I will remove all this. Okay, I will put this, I don't want to do like much work. Okay, now you can see that I am having three functions: human, world, hello. Simple example, easy to understand. Now I am running the program. Here you can see this is the program I am having. Now I am gonna run this. Okay, now to check, or you can see to use the concept of breakpoints, we need to go in this icon, the icon of sources. Click sources, and you can see that I am having the whole code of my document. I am having index.html code and I am having my script.js code. Now you can see that here there are different things like watch, breakpoint, scope, call stack, and here from the call stack section we can visualize how stack is getting created in our program. I will show you in few seconds, I will show you. And these are breakpoints, and using breakpoints we can check how a particular line is getting executed. Okay, so here let's say that I want to check the breakpoint. I want to check how hello world is getting executed. So here I can add the breakpoint. You can see that I have added in the breakpoint section, I have added my hello world. Okay, now after adding the breakpoint, what I'm gonna do is that I will refresh my page. Here I will refresh my page. Now you can see that the breakpoint overall execution has started. Now to check how hello world is getting executed, what we have to do is that we can run the program, right? When we run the program, we can check, okay, hello world is calling some other function, it is calling some other function. Like this, the whole program will get executed. Now if you want to check step by step, okay, after this, what is the immediate step which is coming, after this which is the immediate step which is coming, to check like this, you can see that there is an icon called as step into, you can say under arrow icon, right? Step into next step function call. Now here you can see I want you guys to observe the call stack. I want you guys to observe the call stack. Initially the call stack, in the call stack what we are having, I am having anonymous. Anonymous is nothing but my main program. You can consider it as a main program. Now you can see that when in the main program, what I'm doing is, from the main program I am calling my hello world function. I am calling my hello world function. Let me show you here. From the main function I am calling my hello world function. So here I will go to the next step. What is the next step? The next step is, from main program I have called my hello world. Now check the call stack. In the call stack, from the anonymous, which is basically my main, I have like from main I have gone to hello, right? Now in the call stack the top element is hello, right? Now I will go to the next step. The next step is world. So from hello, the next step is hello. You can see that I will show you here manually. You can observe here clearly. You can observe. Where is my document? Okay. Wait a minute. From main I have called hello, and from hello I have called world, right? And you can see from main I have called hello, and from hello I have called world. Now from world, where I will go? I will go to my human function, and in human function what I will do, first of all I will print my output, whatever there is. You can see that the output we are having is we are printing hello world in the console. Now you can see in the console there is nothing. Now I will print hello world. You can see the returned value is here. The returned value is hello world. In the console I have printed hello world. Now after printing the hello world, what I am doing, after printing hello world, the control flow will come from human back to world. You can see, observe the call stack. Everything is related to call stack here. Now I am in my hello world. The whole control is in human. Okay, sorry, human. Now from human, the next step would be the control will go back to world, and after that the control will go back to hello. After that the control will go back to anonymous, right? Like this you can see that debugger paused. Like this the whole execution will work. Okay, I hope you have understood how we use the concept of breakpoints, debugging, and like this we can check how our function is executing, from where we are getting all this error. Now the next concept we are having is single thread. JavaScript is a single thread language. What is the meaning of it? The meaning is very simple. It follows a structure. It follows a structure, or you can say the execution of JavaScript follows a flow, and that flow will never get disturbed. For example, let's say that I am having 10 lines. I am having 10 lines in my program. First of all, I am having first line, second line, third line, fourth line, fifth line, like this. I am having 10 lines. Now you are running this code. I am having this JavaScript code and you are running this. What will happen is that the first line will get executed, after the next line, after the third line, after the fourth line. Okay, like this, in this structure, in this flow, the execution will get performed, will get happen. Now there are advantages, there are a lot of disadvantages of this. The disadvantage is, let's say that I am having error in line 3. So I have executed line 1, I have executed line 2, but because there is an error in line 3, all these lines, all these remaining lines will not get executed. That is the problem with single thread nature. And because JavaScript is a single threaded language, it has this problem. And let me show you how bigger this problem is and what we do to tackle with this problem. So here I will come back and I will show you here. First of all, let me remove all this and I will print console.log hello world, am Jabir Hussain. Okay, now after this I am printing console.log am Batman. Okay, now let me save the document and I will go to my here. I will remove resources. I don't want resources. I will come back in console. Now in the console I am getting the output hello. Let me refresh this. Okay, I am getting hello world, I am Jabir Hussain and I am Batman. I am getting the simple output. Now let's say that in between this I am printing something which is not like there in my JavaScript. Let's say I am printing a value which is not defined. Now what will happen? You can see I am getting hello world, I am Jabir Hussain and I am not getting Batman, because what is happening is that first of all I am printing my first line. First line is clear, it is getting executed, but there is an error in the line 2. The line 2 is not defined properly. Because the line 2 is not defined properly, I am getting stuck in the line 2, and whatever the lines which are there from line 2 is not getting executed, right? And to tackle this problem, we use the concept of callbacks, right? And one more thing is that the meaning of single thread is that it can do only one work at a time. JavaScript, you need to keep this in your head, JavaScript can do only one work at a time, whereas the other languages, for example C++, Java, all these languages are multi-threaded language. It means that it can do n number of things at a time, right? It can do a number of things at a time, but JavaScript can't do multiple things at a time. It needs time, and there is a big problem with this thing, right? If JavaScript is doing one thing at a time, then what will happen if we build real-time applications? A thing to have a thought of. Okay, for example, if you are not clear, let me erase all the ink. Okay, and I will also remove this also. Here I will remove this. Okay, now I will go in my document. So as I said, JavaScript can do only one work at a time. Okay, and the execution will happen line by line. Our first line will get executed, after the next line, after the third line, like this the execution will work. Okay, now my question is, let's say that I am having 5 lines, a simple code of 5 lines, line 1, line 2, line 3, line 4, line 5. I am executing line 1, I am executing line 2. Now in the line 3, I am using the concept of APIs. We don't know what is API. In the next lecture, we are gonna talk about what are APIs, how we're gonna use them, all these things in detail. Don't worry, but you can imagine APIs as a shop, right? A shop where we are having items, the items which you want. Okay, whatever the item you want, in the API, it's a shop. In that shop you are having everything. Now what we do is that we'll go into that shop. You can consider that you want something. Now what you do is that to get that thing, you will go to a shop, and that shop is API. I'm telling this in a very layman terms, but yeah, it is easy to understand, right? So in APIs, what we will do is that we will ask, okay, give me this, give me that, all these things. Okay, now after asking, what API will do is that it will return something to you. Understood? Now let us say that JavaScript is doing only one thing at a time. So in my line 3, I have called my API, and API will return something, will do some work. Now let us imagine a scenario that this API is very slow. This API, this shopkeeper is very worst man ever. Now he will take 3 hours to give you. He will take 3 hours to perform this work. 3 hours to perform this work. Now what will happen? Like does your program wait for 3 hours? And just imagine, let's say that this is your website and the API is taking 3 hours to execute the third line of your program, third line of your JavaScript. Then nothing will come in your browser. Everything will get stuck. No button, nothing will work. So how are we gonna tackle that? So to understand how we can implement multiple things and how to tackle this problem, if API or something is taking too much time, then how we can go to next lines, and how we can ignore this third line, or how we can put this third line in a separate location and let it do its own work. Until then we will complete rest of our work. How we can do that? We can do that using the concept of callbacks. Like callbacks like set timeout, callbacks like set interval, promises, async and wait functions. We will study each of them in detail in few minutes. Okay, so here let me show you how we are going to use the concept of callback. So here let's say that I want to print set timeout. I'm gonna print console, this I'm going to execute a function console.log hello world in 1 second. Okay, and here I'm gonna give comma tab 1. Here I need to give arrow. Okay, let me save this. So we have already studied in JavaScript part 4 or part 5, we have studied what is timeout, what are timeout functions. Okay, here what I'm doing is I'm printing console hello world after 1 second. When I run the program after 1 second, I'm printing it. Okay, I will copy the same thing and I will print the same thing hello world after 2 seconds. 2, and finally I will print console.log hello world 0 second. Okay, now let me save the program, go to my document, and in the document let me refresh it. You can see that first of all I'm getting hello world, after that I'm getting hello world 1, after that hello world 2. Okay, now you might ask, Jabir, if JavaScript is a single thread language, if JavaScript can do one thing at a time, then you can see that the flow is in this direction. From top to bottom we will get the flow. So if flow is something like this from top to bottom, then first of all we should get hello world in 1 second. After that I should get console.log hello world in 2 seconds, and finally I should get my output. But I'm not getting this Jabir. Why this thing is happening and how this thing is happening? This thing is happening because the execution is happening in browser. Even though JavaScript is a single threaded language, but the whole execution is happening in this browser, and most of the browsers are built on C++, and C++ are multi-threaded language. So let me show you in the diagrammatic format. Let me remove all this. Okay, so what will happen is, here I will have my browser, and I will have my JavaScript. Now in the JavaScript, first of all, I am having set timeout function 1, and after set timeout function 2, after that I am having my console.log hello world. Okay, now what JavaScript will do is that JavaScript is a single threaded language. It will follow in this flow. So here, first of all, it will take this and it will give this to our browser. So it will take set timeout 1. After that, here output, let's say this is our output. Okay, after that JavaScript will come here and it will take this and it will give it to our browser, set timeout 2, and after that JavaScript will come here and it will take this and it will give this statement to our browser, console.log whatever I am printing. Now what will happen is that our browser is a multi-threaded processor, is a multi-threaded, you can say, system, because it is built in C++. Most of the browsers are built in C++. Okay, got it. Now what this will do is that it will check, okay, which one is coming first, this one is coming first, take this and print it. So it will print console statement. After that, which one is coming, statement set timeout 1 is coming next. So I will print set timeout 1, after set timeout 2. Like this, the interaction between JavaScript and browser will work. Okay, got it. Now there is a very important concept called as callback help. To understand that concept, let me go to the console and here remove this, and let's say I'm writing a function set timeout, and I will print console.log, and here I will print hello world 3 seconds. Okay, and here I will give 3000 as my program. So save this and I will go here. Now you can see, refresh the document, I am getting hello world in 1 second, hello world in 2 seconds, hello world in 3 seconds. Understood? We are getting the output. Now I don't want to repeat my lines in my program. A good programmer will never repeat the same thing again and again in his code. I don't want to repeat. Okay, and I know that after each and every second I want to print something. I want to change the color of some thing in my document. So to do that, let's say I'm creating a function. And in the function, let's say my function is change, or you can say print. So print is my function name, printing is my function name, and in the function what I'm doing is, first of all, I will pass my data, what data I want to pass. After that, I will pass my delay, in which time you want to perform this thing. Okay, now I can create my set timeout, and in the set timeout I can print whatever the data I got. So console.log whatever the data I got, here I will print data. Okay, after printing the data, here I can give delay, whatever the delay I got, I am giving it here. Okay, now I can remove all this and I can call my function printing, and I can give here data 1 second, comma, let's say 1000, and I will copy the same thing, and here I will give 2, and I can give here 2, and again 3. This might be a little bit slow, but bear with me guys to understand callback hell. What is callback hell? It is really important to understand this example as well. So let me save this and go to the document, and I will refresh this. It is showing some sort of error. Refresh the document. Okay, in the console, refresh the document, and you can see I'm getting the output 1 second, 2 second, 3 second. Okay, understood. You can see that the code which we are having, let me copy, and the code which we are having before is a long code. When compared to this code is very simple. Here this code is very simple code. In 8 lines we are doing it. Previously we were executing the same thing in 10-15 lines. Okay, so this is a little bit efficient code, but I want to make it much more efficient now. I want to make this code in few lines. Okay, so here I can give callbacks as well. So here I will give callback parameter, and what callback will do is that after each and everything, okay, here I want after 1 second I want 2, after 2 only I want 3. Okay, or I can give you a simple example as well. Let's say we are having ordered data. Okay, I am having ordered data, and understand this very carefully, that I am having ordered data. I want to insert red, after that I want to insert green, after that I want to insert blue. Okay, first of all I want to insert red. After inserting red I want to insert green, after that I want to insert blue. So to do that, you can see that this is dependent, right? First I want red to be there, after that I want blue to be there, green to be there, after that I want blue to be there. So this dependent structure I want to perform. So what I can give here is I can give my callback function, and in the program I will call my print program, and here I can pass initially my red data. Okay, and the timeout would be 1000. Okay, now here I need to pass my function. So here I will pass my function, and in this function again I will call my printing data. Now after inserting red I will insert green. If there is no red, then there will be no green. Okay, now I will give 1000, and again I need to give arrow. Okay, again here arrow, and after inserting green I want to insert blue. 1000, and this thing. Okay, now I will call my I will give here blue, and let's say I will print completed insertion of colors. Okay, this is totally, I know this is totally a little bit confusing and upset why we are doing it, why we are spending our time in it, but give me some time. Call back hell is really important concept to understand, and it is really the thing which is there to understand the concept of databases. If you don't understand the concept of callback hell, then we cannot understand why we are using some things. Okay, so give me some time, everything will be clear. Okay, save everything. Okay, so what we did, we basically concised our program, and we made our program in such a way that it is dependent on one another, right? After red we will get green, after green we will get blue, after blue we will print completed insertion of colors. Okay, like this a dependent insertion or dependent data will get formed in our browser. So let me see the output. So here let me refresh the document, and in the console you can see that first of all I am having red, green, blue, and here refresh red, green, blue, and go to the next step. Yep, you can see I am having red, green, blue, and finally here you can see completed insertion of colors. Ignore this error for now. Okay, we are getting the output something like this. Let me go up. Okay, anyways, we are getting the output, right? I am getting red, green, blue, and completed insertion of colors. Now you can see that this nesting of callbacks, first of all I am calling my function print function. Inside that I'm calling, inside that again I'm calling, inside that again I'm calling. So this nesting of conditions, this nesting of, you can say, callbacks is known as a callback hell. And I know it is really confusing to understand this code, why we are doing it. So to understand why we did this, let us take an example. Let us take an example of a login page. Okay, you are creating an account. Let's say you are creating a YouTube channel or a writer's profile. Okay, you are making a writer's profile. Now we have imaginary hub X platform, right? Now in X we follow a set of procedure, right? There is a set of procedure which you have to follow in order to become a writer in our platform. I'm not promoting my platform, but yeah, so what will happen is that the first step is you need to create your sign up process. Now after sign up, you have to agree to our terms and conditions. There are set of terms and conditions which you have to follow as a writer. Now after terms and conditions, the third condition is you have to make your writer's profile. After making your writer's profile, you need to create, or you can say customize your dashboard. Now after customizing dashboard, you can write and publish your own articles in our platform. This is the flow of program. Okay, now imagine this as a database. Okay, now you can when we imagine this as a database, now we want the user to follow this step-by-step process. We don't want our user to directly come to publishing page. He can't directly go to publishing page. Okay, he need to follow a set of things. And the set of things is first thing, after the second thing, third thing, fourth thing, fifth thing. He can't directly come from first thing to second thing, or he can't directly go from first thing to fourth thing. It cannot be possible. To create this sort of data structure, we use callbacks. And if we use this callbacks, now here you can see I have used an example. Like for example, first of all I am getting red, after that I am getting blue, after that I am getting green, blue, something like this. Imagine this as a database. You are inserting some data, and after completing each and every insertion, you want to go into next step. If there is something error, then you don't want to go into next step. You want to stop that thing immediately. So that thing, this whole structure is known as callback hell, and to tackle the problem of callback hell, we use the concept of promises. Okay, here what is a promise is an object in JavaScript which is used to tell whether a thing is a complete or not. Okay, for example, let's say that you are making your profile. You are making your profile in a platform. That platform is, let's say, Twitter. Okay, you are making your profile in Twitter, and that profile making is totally dependent on internet speed. Whenever you give your image, your data, your biodata, your date of birth, all these things can be saved in the X database if and only if the internet is fast. If your internet is slow, then the insertion of data will get failed. Okay, now this failure and success, insertion of data completed, insertion of data got failed, these two things can be demonstrated using the concept of promises. Promises is an object in JavaScript which will tell whether the operation is completed or not. Okay, and it will give you two things in return: resolve and reject. When the insertion of data is completed, success, it's a successful event. When a thing is successful, we'll get resolve. If a thing is failure, then we'll get reject. So here let us take a simple example. I will remove all this and I will create a database, a simple database. Let's say I'm creating a database as a like simple example. So we don't know anything about database, that's why we are creating a simple function and we are gonna imagine this as a database. So I will give save db, save database. In this I will pass my what you can say data, and I will pass my success, and I will pass my failure. Okay, I will pass my failure. Now this data insertion is totally dependent on internet, and this internet ranges from, let's say, 1 to 10. So to take a random value from 1 to 10, I'm going to use my math.random function. So here I will write I internet speed is equals to math.random, before that math.floor, math.random into 10 plus 1. Okay, I am getting the I value. If my I value is greater than 10, then what I will do is that I will call my success function. I will call my success function. If I value is greater than, let's say, 4, which is I am having good internet, right? I will call my success function. Now else I will call my failure function. I will tell my user that the data insertion is failed. Now I will call my save to db function. Here I will pass my data, let's say imaginary hub, and I will give my function, success function, as console.log data is successfully inserted. Okay, or if I get a failure condition, then I can give here, I can create my another arrow function, and in this I will print console.log, and here I will print fail of adding data. Save this and go to the document, and I will stop my process, debugging process, refresh this. Okay, in the console you can see that I got the failing of data. Now if I refresh this, you can see I'm getting some random value, data is successfully inserted. Along with it I will print the data speed also. So here I will print console.log internet speed is, and I will print the I value. Here I will print console.log data, whatever the data I have passed, I will print the data. Okay, copy this and paste it here, save this. Okay, now you can see my internet speed is 6. If my internet speed is greater than 6 or greater than 4, I will successfully insert the data, imaginary hub. I will insert this into my database. Now I will refresh this. The internet speed is 3. If it is less than 4, my insertion will get failed. Like this we can create our simple database. Okay, now how we gonna use the concept of promises is here. So like this we are having our sample database. Okay, now we know what are promises. Promises will tell you whether one thing is completed or not, and you can see that our program is sort of huge. We can concise this whole thing using you can say promises. Using promises you can tell whether one thing is successful or not in a very simple terms. So here what I'm gonna do is that I will remove all this. I will remove this also, and in place of adding this success, failure, all these things, I will remove all this and I will return new promise. I know what is promise. Promise will do, promise is an object and it will tell you whether one thing is completed or not, one thing is successful or not. We can tell this easily using the concept of promises. So here I will write resolve, comma reject. Resolve is successful event, reject is unsuccessful event. Now in this I will write let I will check my internet speed. So math.floor, and here I will write math.random into 10 plus 1. Okay, now after calculating the internet speed, I will write if my internet speed is greater than or equals to 4, then I will print resolve. In the resolve I will write saved successfully. Okay, now if the internet speed is less than 4, then I will write reject, and here I can give failed to insert. Okay, now save the document and go to the console. Here I will give save to db. I will call my save to db function. I am having this, and I will pass my some data. So save to db, and I will pass my data imaginary hub. Now you can see that promise is fulfilled and the data is successfully saved. Now if I copy the same thing, now I will copy the same thing and I will do it again. You can see again successful, and again successful, like this. You can see we got successfully inserted, all these things. Promise fulfilled means we got a successful events. Like this we can see if one thing is successfully inserted into our database or not whenever we have a lot of dependent data. Okay, now you can observe that the program which we have before promises is a little bit complex and a lengthy one, but when we use promises, the whole program is little bit tiny and it is easy to understand. That is why we use the concept of promises. Now similar to promises, there is another concept called as async and await functions. So let us see what are those. Now the next function we are having is async functions. So using async functions, we can do multiple things at the same time. You can say tackle the problem of single threadedness of JavaScript using async and await keywords, async and await functions. So let us see how this thing will work. You can see I have taken an example. At each and every second I am printing different colors. So what this will do is that it will wait for each and every second, and we can do multiple things at the same time using async functions. So let us understand this. Here let me comment this thing all out. So I will comment this thing. Now async, and here I am writing, right? So here async and await are objects in JavaScript, are objects, and it is very similar to promises. What promises will do, whenever you insert something in your database, it will tell you whether that insertion is completed or whether that insertion is rejected. Okay, it will tell you, it will give you the information of that. Similarly, async and await are also the same. It will return an object, a promise object, and it will tell you whether the insertion is completed or not. And async and await are very simple and easy to understand. Here, for example, let's say that I am using async keyword, and I will write my function, async function, let's say greet. Okay, now here I will return hello world. Now I will call my greet function. So here call my greet function, greet. You can see promise got fulfilled and the value or result of that is hello world. So async and await is also a function, an object in JavaScript, a promise object which will return whether one thing is completed or not. You can see the promise is fulfilled. If the promise is not fulfilled, if there is an error in the program, then it will tell me that there is an error in the program and the promise got rejected. Our promise got not satisfied or not fulfilled. Like this, we use the concept of async and await, and using async and await, we can like implement the nature of multi-threadedness. Not exactly multi-threaded, but yeah, we can make our program to execute multiple things. For example, here I can write my program. Let's say that I want to execute different things at the same time. Okay, so here I will write async function, and let's say my async function name is show, and I want to show after each and every second I want to print a color, right? So here I will print I will call a function, let's say print, and here I will pass my data imaginary hub, comma 1000. Similarly, I will copy the same thing, paste, and 2000, 3000. Okay, now we need to define our function imaginary hub. So here I will call my function, let's say function print. I will get the data, so print, I will print console.log data. Now let me save and go to the document. I will call my async function, which is show. So here, this is my show function. I will call it. Now you can see I got the imaginary hub. Like this, instead of, you can say, previously we used to do multiple things in different lines, but we can do the same thing in few lines using async and await keywords. So to tackle with callback else, we use mainly two things. First one are promises, and the second one is async and await keywords. So till now we have talked about what is a call stack, what is a breakpoint, how we can debug our code, what is callback hell, JavaScript single threadedness, and we have seen promises and async and await keywords till now. Now the next lecture, I know this lecture is sort of hard to understand and we haven't studied anything about databases, but here we are trying to visualize our database. But yeah, it is sort of confusing, I know, but if you watch the lecture again and again for few times now, then you will get the point. And when we study databases, after backend we will study databases, but it is going to be a lot easier, believe me when I say that. Okay, and yeah, this is about the lecture. In the next lecture, we are going to talk about APIs. APIs are one of my favorite topics and it is going to be very interesting. So with that being said, I will see you in the next one.